All right. So, what I have for you guys today is a sort of very basic, uh, like chat room application that doesn't involve any front end or HTML. So we're going to make an application that can start up a server using Node that will handle incoming connections and messaging and passing it back and forth to the clients. And then we're also going to implement a separate client application that you can type into your command line, and it'll go ahead and start sending messages to the server. So there's two different pieces here. Um, this Kangaroo demos slash sockets folder. Um, this is the source that I uploaded last night for everything that we're going to write today. Feel free to look at this in advance, but by the end, we should have basically the same thing. Um, and the link for this is on the agenda if you want to reference it at any time. All right, so with that said, let's talk about socket.io first. So the goal of today is we want to get a little bit of a practice handling callback functions and events. There's a number of tricky things around events in Node.js, some of which I found out firsthand trying to write this application yesterday. Um, if you'll remember from the content this week, Node.js uses an event queue system. Um, so what the Node.js event queue is going to do is it's going to process all of your code from top to bottom until it gets stuck. And once it gets stuck and it can't get any further, or it's completed all of that code, it will look for a callback queue. And a callback queue is all of those events that we registered a callback for in the past. Um, but we did not have the ability to finish right away. And once those events do actually occur, down here in this callback queue, once those events are satisfied, so in the case of a timeout, the timeout has passed, and now we're going to execute that function. Or maybe what we're going to see today is a connection was made to the server and someone sent a message. And so now that message is available for us to read from the server. And we're going to register a function that allows us to actually read that message and do something with it. So once those callbacks are ready, they're going to get stuck down in the callback queue, but they don't get pulled off of the queue until this call stack is empty. So my call stack starts by doing something and then console.log and then set timeout and then console.log. And once I have hit the end of what I can execute sequentially, the call stack is going to be empty. Let's run this and see what happens. All right, so we're moving down the stack. We're executing web APIs that's going to register a callback. And when that callback is finished, that now becomes the stack. That was really fast. I would love it if we could slow this down. But I don't think that we're going to be able to do that. But what's happening here is we're going top to bottom. We're registering things that in the future are going to have a callback function and letting them finish. And once they're finished, they get moved into this queue. And this queue is what we then pull onto the new call stack. The call stack is what our application is actively performing.
The
Um,
console log statement also entering to the call stack, or
That's it. Yeah, that's exactly right. So all these things in our program, we're executing sequentially top to bottom, including this console.log. We don't actually really see it in the call stack here, which kind of sucks. But what it's going to do is it's going to stick something onto the stack that we need to do. And we need to do the console.log, which happens immediately. And then we move on to the next thing. We set the timeout. The set timeout happens on the call stack. It sticks this callback function into this thing that's going to happen in the future section. And after 5 seconds, that gets moved down to the callback queue. So it's just a shuffling of things to determine what is actually going to run. And what is currently running is on this call stack. So we need to keep this in mind as we're going through sockets, which we'll move on to in a sec, unless there's any other questions about this little tool. I'll add a link here in the agenda. I put a link last week, and I think there might be a link in in the lesson for this week. I don't remember exactly, but I thought this tool was really cool when I saw it going through the content, just so you can visualize some of this. All right, let's talk about sockets next. So, sockets are a really cool way for passing messages between a bunch of different applications connected to a server. And it's going to happen like almost immediately. There's very little structure in how the messages need to be sent, which gives you a lot of flexibility. Um, in comparison to what you would think about with a traditional HTTP API. Um, an API specifies usually a specific set of things that a client is allowed to do on the server, and it gives a really strict contract. You have to send me a request to this particular URL. You have to give me this very specific data, and I'm going to give you back this other thing according to the contract. Sockets are really cool because you literally are just like sending some data and it's going to get serialized, which means it gets turned into ones and zeros. There's some strategy that is going to be performed to serialize whatever piece of data you have. If it's a string, it gets serialized one way, a number a different way, but they all end up in ones and zeros. And then those are transmitted through the network over the air to another person, and then they get deserialized. Deserialized meaning taken back into that string or that integer format from those ones and zeros. Um, so all we need to do is we need to be able to send the data back and forth, and we need to have something on either side that knows how to do that serialization and deserialization. And socket.io is going to help us with that, and it gives us a lot of really cool options. Typically, you want something like this if you need real-time communication, something that's just going to happen instantly and someone can react to. You don't want anything to go slow. You don't want any like super difficult contracts. Um, the most common example, which we're going to do today, is like a chat room. If you're messaging someone, you just want to send data as it's being produced to the other person, and you're both connected at the same time to each other. There's lots of other things you can do with this. I've made some personal projects for school that I've made a couple of different games that use socket connections to communicate things that are happening. Like if someone has started a multiplayer game, you don't really need to like persist data about what's happening in the game. You don't really want to use an HTTP API because like you could be sending a bajillion different pieces of data and it doesn't really make sense to structure that in a contract. Rather, what you want is some server running in the background that is able to host this socket server that's able to accept connections from all the different players and receive data real time about what they're doing, make decisions about the state of the game, and then send that state back to the players so they can see what's actually happening. That's an oversimplification of how it works. It's not going to work the same for every game, but this is sort of an idea of how you might accomplish some of those things. So what we're going to do today is we're going to make a really simple application that starts up a server and accepts connections, and then we're going to make the other side of the application, which is all the people connecting to the server and sending data back and forth. Questions about uh, anything, background information that we just talked about before we jump into some code? All right, I'm going to take that as a no. All right. So with that said, we're going to um, open up a new project. We'll call this Sockets Demo Live. We'll get rid of that old typo branch. All right. So if I go into my VS Code, I'm going to have all of this stuff left over, but let's start from a clean slate here. So I'm going to get rid of all the files that I have in here. Just pick somewhere on your desktop that you want to make this application, doesn't matter where. And we're going to start with npm init, which will create us a new node project. We'll keep whatever the name is, description, entry point. We don't really care about any of this right now. We'll go back and revise it in a second. It's all good. All right, so now we have our package.json. Let's fill out this package.json. We're just going to use modules rather than common.js, which is what my VS Code always tells me to do anyway, so I'll just make it happy. We're going to take out this test script. We don't have any need for this test script. It doesn't do anything. And we're going to have two applications here. We're going to have a client and a server. So let's create scripts for both. Let's say our server is going to start up if we call start colon server. And what is this going to do? Well, this is going to run with node server slash index.js, which doesn't exist yet. We'll create it in a second. And same thing for the client. We want to start the client application, and we'll create a folder client and put an index.js in there as well, just so we can separate these two and have a little more distinct visual clarity. So we'll create our server package. We'll create our index.js in there. I am server. And let's create our client. We'll create our index.js. Console.log. I am client. All right, we're just putting in some demo stuff here for now. We're not going to do anything crazy here, but I do want to test this out and see if it worked. So I'm going to open up the terminal in my VS Code just because I think that'll be easier than constantly switching back and forth between my actual terminal and VS Code. We're going to make the terminal and we're going to stick it down here so it's a little more visible. All right, we got our terminal. And how do we run these scripts? Well, we're going to use npm run and the name of the script that we want. npm run starts server, prints I am server, which is what we told it to do. npm run starts clients. I am client, which is what we told it to do. Great. So we know it's running the right files. Now we can get to the cool stuff. Do I need to slow down? Do I need to stop? Any questions? All right. Please leave them in the chat at any time if there are any. I don't know if I'm going too fast unless you guys tell me. All right, let's make the server first. This will be the easier part. There's some weird stuff in the client side of things. We're going to get rid of this, and we are going to just create a new server that we can do stuff with. And how do we do that? Well, we use the HTTP module, which comes with Node by default. And this should be relatively familiar from some of the other assignments that you've done in the past 2 weeks. We're going to say our server is equal to http.create server. And what does this want? This wants a request listener. And it gives us back an HTTP server. So we could do some stuff in here if we want to, just to get this to work. But we're actually going to leave this alone for now because we don't actually really need this. And we're going to do server.listen, and we'll make it listen on port 3000 arbitrarily. We're not going to talk about ports in particular here. And so now if I run my script, npm run start server, I don't actually know if this is going to work or not. Yeah, so it is running, but it doesn't do anything yet. We got to do all the cool socket stuff first. So let's switch back over to our socket.io documentation here. I'm going to go into the getting started section, which is usually just a small little tutorial about some of the main concepts. So we're going to follow partially their basic chat application. They're going to create like an HTML front end, which we're going to avoid. We're going to stay purely with Node today. All right, so we have our project initialization, we have our package.json, and we need to install a couple of things. First, we need to create our HTTP server. Um, we're going to just go ahead and do what they recommend and install Express, which is a package that comes with all kinds of goodies that you don't have to manage yourself, which is really nice. Are we gonna like do any of the cool Express stuff? Not this week. We're gonna leave that for next week. Um, but you can certainly look ahead if you want to. I will add this to the links in the agenda. But essentially, Express is just going to help us create a server that we can run somewhere and we can connect to. So let's install Express. Not in there. Said I was not going to use that. We're going to do it down here in our terminal. PMI Express is going to install Express. And let's do this boilerplate that it wants. So it wants us to call this default function that's exported from Express. And then we're going to provide that to the server, which is going to provide it with all the default options and so on and so forth. All right, so let's do this. We're even just going to put this on the side so we can see what we're referencing as we're writing some code here. So we're going to import Express from Express. What is this doing? This is a default function. So the default export of this module is a function rather than maybe an object or something. And this function is something that we can then call. And when we call this, the new type of this object is this express thing. What is this? This is what handles our request and our response. I see someone raising a hand. Go for it.
Excuse me. As I understand, we installed the fifth version of Express, but in the documentation, we need to install the fourth version.
Yeah,
Or
I just installed whatever the most recent version is. I don't think it's going to matter at all. Maybe they've tested out version 4 and are recommending that. Uh,
okay,
I
thank
am just going to stick with 5. Feel free to do number 4 here. It never hurts to follow documentation. This is maybe like a calculated risk. I don't think it's going to matter at all, but feel free to do version 4. That's totally fine. All right. So we have our express function, which is going to create us a request and response handler. And then we're going to provide that handler to this create server option. This is common nomenclature to just call it app. I don't know why we do that. But now we have our server and we can define specific API routes. So these are HTTP API routes, which we are not going to stick with for very long, but let's create one just to know that it works. And don't worry about the syntax here. This is a problem for next week. But let's res.send pong, and we'll call this /ping. This is a common pattern where you send a request to /ping, it sends you back pong. You can time how long it takes to do that, and you can generally get a feel for how latent your server is. And then we're going to listen on port 3000. We can optionally register a callback for when our server successfully starts up. What do we want to do? Well, we'll console.log server is now running on local host 3000. Localhost is like an address that only exists on your device. It just looks for something running on the given port of your local machine and doesn't do anything on the network. So this is pointing at the server running on our machine. And let's npm run start server again, just to see how this works. We now have localhost 3000. And it's going to tell us we can't get just a basic slash because there is no route here. We only define one at /ping. We go there. Now we get pong back. Why is it so big? I have no idea. It must be way zoomed in. It probably will look more like this big. Oh, all right. If you can see this, then we have our server running and everything is hunky-dory. Questions, comments, concerns? Should I slow down?
Could you share packages on file, please?
Yep. All we did was run npm install and express. Should not have to do anything else yet. We're about to install socket.io, but we're not there yet.
Thank you.
Cool. Anyone else? All right, let's keep moving on to the cool stuff. So you'll notice already we're starting to handle events here. Um, this is this is the pattern in Node and in JavaScript. What is happening here? Well, the server is starting up, and once it's finished starting up, this callback that we have registered to Express under the hood is going to execute. And so this console.log only happens once it is finished. Similarly, up here, Express is saying, when I get a request sent, a GET request to /ping, then this callback function, which handles the request and gives some sort of response, is going to be executed. And so when I call /ping, it runs this code and it sends back the response pong. So we're already hooking into events. Our code executes from top to bottom almost immediately. There's nothing holding it up. All it's doing is registering some callbacks to happen in the future. If we go back to our loop demo from earlier, essentially what we're doing is we have our call stack. Oops, I don't want to run you. Great video, but we're not going to listen to it right now. We're running from top to bottom. We're executing some things. It's going to register these callbacks over here into this API section. Web APIs doesn't really apply here since we're not running in the browser. But essentially, it's doing the same sort of thing where it's storing these callbacks for later. And once those events happen, it'll move it down into the queue where we can actually process the results. So it's going to run top to bottom. It's going to finish very quickly. It's going to register stuff in here, and then it's going to sit and wait until one of those things happens, and it can move it into the queue and up into the stack to be executed. Oops. All right, so now we're going to throw in even more variables here, and we're going to start doing the socket stuff. All right, so socket.io is comprised of two parts. So it is a server that mounts into an HTTP server. So we have our HTTP server here. We have Express, which handles a lot of the internals for us. And we're going to basically just stick socket.io on top of that so that socket connections are also accepted by this server. Right now, it will only accept HTTP connections and requests, but we're going to set it up so it also will accept sockets, which uses a totally different protocol. And then separately, we're going to create a client that is going to use the other half of the socket.io library, and it's going to send those requests using that socket protocol. So let's install this. We need to run npm install socket.io. This terminal kind of sucks because it's so wide here, but npm install or npm I is fine, socket.io. We're going to need socket.io -client, but we're not going to do that quite yet. We'll leave that for when we get to the client stuff. All right, and now my package.json should have that in my dependencies section, the socket.io. All right, now let's set up that server on the server side. So we are going to import from socket.io. What is this thing we're importing? It is this absolutely disgusting type over here, which we're not really even going to think about too hard. But whatever it is, we want to create a new version of it using this HTTP server. So it's going to take this HTTP server, it's going to set up our WebSocket acceptance connections, whatever you want to call it. And then now we can actually do stuff. So this IO is this socket server object that allows us to do all kinds of things. The most common things you're going to use are emit, which sends a message to someone else. In this case, the server sends a message to the clients. Or we're going to use io.on, which says listen for a message over a particular topic or a particular subject. The subject in this case is connection. This is a reserved topic or subject, whatever you want to call it. This is specifically an event that socket.io broadcasts when a new client has connected to your server. So what we can do is we can say on connection, let's take that socket that is connected and we're going to register a callback that is going to happen when that socket connects. What are we going to do? We'll keep it simple for now. Let's just console.log a new user connected with ID socket.id. This is a unique identifier for this session between the client and the server. All right, and we're not going to touch anything else here. All we need to know is that things were connected successfully. And now we need to set up the client so that it can connect to the server and we can know that everything's still working. So let's start up our server for now, just to make sure we didn't make any typos. Nothing exploded, which is good, but we don't have any way to connect to this yet. So there's not anything happening here. So let's jump into our client and we're going to do some client stuff next. So what do we need? We need that socket io-client. This tutorial is only going to really help us if we're using an HTML page, which we're not going to do here. So we're going to sort of break away from this for a second, and we're going to do this part manually. So we're going to create another terminal. We're going to put it on the side over here so we can see both at the same time. We're going to npm install socket.io-client. Now our package.json should have that socket client library down here. And if we npm run start client, we haven't done anything, so it still just prints out that message. But now we're going to actually do some cool socket stuff. So what are we going to import? We're going to import from socket.io-client. And we're going to see if it's a default export. Yes, I think this works. Let's try it out. This is also a default export function. That this is a really disgusting help message, but essentially what we're going to do is we're going to pass in the URL where our server is running, which is running on our machine. So we're going to use localhost and it's running on port 3000. So we're going to give it that URL of where can it find the socket server, and it's going to give us back a socket. You'll notice over here that when we actually create the server, this one says server and has a bunch of event stuff in it. This one says socket and has a bunch of event stuff. We now have the two pieces that are running together. So we could do all kinds of other stuff. We could do socket.on again and say when we connect, then we're going to broadcast console.log successfully connected to server. And let's run this, see what happens. So we have our server going over here. We have our client over here. We're going to clear this out. If we npm run start client, we got some cool stuff here. So we notice on the server side that this connection event finally happened because someone connected a client to the server, and it prints the ID of the socket that is connected, the session. And then over here, we see that once the connection is successful, which this is not going to happen immediately, it might happen a very, very small amount of time in the future, like it is here, because it's all running on our machine. If we're connecting somewhere way far away, it might take a very long time. And so as a result, this is an asynchronous callback that we register. And once it successfully connects, then we are able to connect to the server. You'll remember that we also said the other thing you're going to be doing a lot is emit, which publishes a message over a particular event. This message doesn't actually just have to be a string. You could publish like any amount of data you want. And as long as your server knows what data to expect, it will turn it back into that same data. But you can also just publish a basic string, which is what we're going to do here. But just keep in mind that you can publish multiple things. You can publish more complex data, anything you want to. Let's call this to server to indicate the direction. So this message is being sent from the client to the server. And we're going to send foobar. Can anyone tell me or posit a guess? You don't have to be right. It's totally okay. Do we think that this is going to work? Do we think that the server is going to get this message foobar? Actually, before we answer that question, let's set up the server so that it listens for this message. I guess I should have made one of you guys do that. That was stupid. But anyway, if we're sending a message over to server, then we need to listen on that same topic to server. And what are we going to get? Well, we're going to get a message string. And what are we going to do with that? We're going to console.log sent to server message string. All right, so now we theoretically have a handler here for to server. Does anyone maybe see well, this is a terrible question to ask. Does anyone possibly see what's an issue with this statement right here? Any guesses? This one's pretty hard. All right. So, we got a guess maybe? Not seeing an issue. All right. Yeah, it does look very, very normal. And it's almost normal, except we got to remember, where is this message coming from? This to server message is coming from our client. We are sending a message to the server over this topic, and we're sending this message foobar. But this on registers a listener to what is our socket server over here, when really we want to register this onto the socket that is connected. And so the pattern here is actually that we want to put these listeners on the socket that's sending the message rather than onto the generic server. I don't actually know what this is going to do, and I'm kind of curious, so we're going to test this out a little bit later. But what we generally want to do is we want to register all of these things that are going to happen to the socket. So when this client socket that is connected sends a message over this topic, then we're going to handle it. Down here, I don't know what this does. This honestly might listen for all messages over this topic from any socket, in which case maybe it still works the way we want it to. But usually if we want to interact with this specific socket, we're going to have to put this where this socket exists inside of this callback. This looks really complicated, but this is typically the pattern that we go by. So after the socket is connected, then we're going to register a bunch of listeners on this socket. So what is this actually able to do? Well, it can send messages over this topic. We could register more. We could say topic number 2. And then here we expect that maybe they're going to send a number. And then we console.log the number plus 1. How about that? And let's actually go down and also use this topic here in our client. So we'll also send a message over this other topic, topic number 2, and we'll send a number 3. So we would expect that this goes to the server, it gets incremented by 1, and then we log 4. We're gonna have to restart our server since we just modified it a little bit. Oh, other really cool thing to note is our client disconnected when the server stopped, and then it just automatically reconnected itself. That's kind of awesome. If the connection goes down, if it gets dropped for some reason, it's going to recover. You don't have to handle any of that yourself. All right, so now we want to run this client, and it's going to connect to the server, and it's going to emit these 2 messages. Let's maybe do like a vote in the chat. So react to this message. Let's do react with a thumbs up on the message if you think that this is going to work and we're going to see these things printed to the console. And maybe react with the fire emoji if you think things are going to crash and burn and it's not going to work. All right. Catherine's an anarchist. She thinks it's going to crash and burn. Anyone else? All right. Let's try it out. Let's see what happens. So we are going to npm run start client. Oh, it does work. Interesting. All right. So my expectation here is that this probably should not work or is going to lead to some buggy behavior. It did actually work in this case, which I'm a little bit surprised by. I guess I should have tried this on my own. But again, the important thing to note here is that this socket might take a long time to connect. We have no idea how long it's going to take. It might take a long time, might not take that long at all. I don't actually know if there's a way to like simulate this thing taking a long time. I think I would need to like write some code that can intercept the connection and then like create an arbitrary delay. But this is too low level for this example, so we're not going to do that. So let's say this connection took like 4 seconds and took a really long time. All this does is register this callback function. That's all it does. It doesn't actually like execute it. It's just saying stick this in our little box for the future of things that have not executed yet but have a registered callback. And when it successfully executes, when we make that connection, then you can stick it in the queue of things that need to be processed and we can go ahead and do it on the call stack. But that is not going to happen until we have successfully emitted these things. So we are going to register this callback. It might happen in the future. We're going to connect at some point. It might happen in like 4 seconds. It might happen in 4 minutes. It might happen in 4 hours. Or it might happen so incredibly fast that we don't even notice, which is what happened here. But these emit statements are going to happen before we've actually successfully connected. How does this actually still go through? My expectation would be that it's going to basically just like hold on to these until the connection is established and then just like shotgun them once the connection has completed. I don't actually know if that's the case. I haven't looked at this super in depth. It's also possible that the connection just happened so fast, it was immediate that like it didn't even matter. And before we got to the next emit statement, we were successfully connected, and so it just worked. Um, but the moral here is that generally, if we want to use this socket, we should put all the code inside of this connect callback. So only when this thing is actually successfully connected are we going to emit these messages to the server. And now we get them again, foobar and for. Let's actually show one more thing in here. This is another thing that you might have picked up from the video this week. End of file. If I run this, put some other messages in here. What is the order in which these console.log statements are going to be printed out? Let's throw all four of them in the file here. So I'm going to minimize this. So we have four console.log statements. We have connected to server, emitting one, emitting two, end of file. What do we think is the order in which these are going to be printed out? Maybe let's do this in the chat. So maybe if someone could give me what statement they think is going to happen first. All right, we got to vote for random. So maybe every time we run it, it happens a little bit differently. Anyone else have a thought about maybe which one gets printed out first? End of file first. Okay, we got to vote for this. Any other votes? You can also just like thumbs up an existing message if you agree with it. All right. So we got one vote for random. So that's one option. So changes every execution. We have a vote for number one, end of file. What do we think is going to be executed second? Which statement comes next?
The successful one?
Successful connected to server, you mean?
Yeah.
All right. Connected to server. All right. And then what do we think is 3 and 4? I can probably guess from here. So we think end of file is first, and then probably emitting 1 is next, and then emitting 2 is after that, since they happen to. Anyone disagree with either of these? Any arguments why? Any other suggestions? All right. I don't know how to do this in JavaScript. I would totally do this in Golang, which is what I'm more comfortable in, and I do at work. But there's such a thing as like a benchmark test, where basically what you do is you take like a piece of code that you're testing and you basically run it like 1,000 times. And when you run it 1,000 times, it's going to measure how long it took each time. And it's going to run it with a bunch of different inputs. And it basically just measures at different sizes of input. So maybe we have like an input of a slice of one thing, or an array of 10 things, or an array of 1,000 things, or an array of 100,000 things. Like how does it scale as you go? It would be really cool if I could just like run this 1,000 times and capture the output each time and make sure it's the exact same. I don't know how to do that here, so we're just going to run it from our terminal and make sure that the output is consistent. npm run start client. All right, so we have end of file, successfully connected, emitting 1, emitting 2. That's one of our options that we came up with. If we do it again, end of file, end of file, end of file. All right, that looks pretty consistent to me. So in this case, we're going to say this is probably deterministic. It's going to output the same thing every time. So what we pick up from this is a reinforcement of exactly how that event system works with that call stack and whatnot. So one who doesn't know everything there is to know about the event queue might decide that sometimes this would get printed first if the connection takes a long time, and sometimes it'll get printed afterwards if the connection is really fast. And so maybe these statements happen out of order sometimes. In fact, that is not exactly the case here. It is deterministic because if we trace through the execution of this program, what's going to happen is we're going to start with our call stack and we're going to go from top to bottom and do a bunch of things here. So we're going to create our new socket connection, and then we're going to call socket.on. And this, again, is not actually running this code right now. All it's going to do is it's going to stick that callback function somewhere in memory to be executed later when a particular event happens, when this socket connects. So it's going to sit in this web API section over here until that connection happens. And that connection might be really fast, in which case it immediately gets thrown onto this callback queue, which is probably what's happening here. Like our server is running on our machine. It doesn't have to go over any network. It's probably just going to be really fast. Or maybe it takes a really long time to connect. Maybe you're hosting your server like on AWS or on some cloud provider where the machine is very far away from you and not something that you manage, and maybe has a bunch of firewalls that cause it to take longer to get to your server, in which case maybe it takes a second or two to connect. In that case, maybe this gets stuck on here for a little bit longer and we can execute this console.log before this is fulfilled. But either way, this is going to be sitting here. It's going to end up on the queue, but the queue, we cannot pull anything off the queue until we have nothing left to execute procedurally from top to bottom in our call stack. Only once this console.log completes and our call stack is now empty and there's nothing left to do, are we in fact going to be able to process whatever's on this callback queue. So it will always register this callback. Whether or not it completes instantly, we don't know, but then it will proceed to the last instruction, console.log, into file, and then it will stick that thing. It'll take it off the call stack. We now have nothing left to execute, and all we can do is wait for events to succeed, and then we're going to do that callback, and that becomes our new call stack. We could prove this even further by doing a timeout. So after a certain amount of seconds, what are we going to do? We're going to console.log finished with sleep. And this one is going to happen after 2 seconds. One run starts client. So we still get the same ordering here, and this callback was registered first, and it's going to complete very, very quickly. It doesn't actually matter that this was registered first. It just matters that it got completed first, and it goes down onto this callback queue. And the set timeout, this happens 2 seconds later, and then it will also get pulled down onto this queue. But at that point, we've already executed all of our stuff here in way less than 2 seconds. And so this will happen at the very end. You might have seen in the demo video that you can set a timeout that waits no time. It instantly finishes. Um, and the reasoning for doing this is you want something to happen basically like after you finish the call stack, but you don't want to like assign it a specific event or an amount of time. So this is going to immediately stick something into this pending section of callbacks. The event triggers immediately. There is no wait. And so it sticks it on the callback queue immediately as well. But we're still going from top to bottom procedurally. We haven't finished out our stack. And so that's going to sit in the queue for a little bit. It's going to add this other event, which is going to happen very, very quickly. And then once it's all finished, then we're going to resolve those in order. So we should always see that this up here, which immediately goes onto our callback queue, will execute before all of the stuff inside of this connection callback, just because this one was registered after this one already finished. So if we run this, we should see that finished with sleep is our first message. Yeah, so it executes top to bottom. It prints that we're at the end of the file. We're finished with sleep, and then we're allowed to move on to the next callback. One other quick thing, I'm just like thinking of things from the video that might be helpful to mention to you guys just for understanding, is this callback queue. A queue is a specific data structure, which is just like a really fancy way of organizing data. And the data structure is designed so that when you stick things into the queue, they are pulled out in the same order that they were put in. We call this first in, first out, or FIFO. This is in comparison to a different data structure called a stack, which is last in, first out, or LIFO. The difference here is if I have a queue, let's say my thing finishes and I stick it onto the queue. I'm going to stick it in from one end and it goes to the front of the queue. And then I get another thing that finishes and I stick it in and it goes to the second place in the queue. I have another thing that finishes and it goes in and goes to the third thing in the queue. We are only allowed to pull those events out of the queue and handle them in the order that they were put in. We want the thing that resolved first to be processed first. Naturally, it would be weird to do anything else. So that first callback that is ready to be processed is going to be pulled out. Now there's two things left in here, still in their same order. We're going to process that. We're done. Now we have another thing waiting for us. We're going to pull that out. We're going to process it. Now there's only one thing left in here. Then we're going to pull that out. So the order in which they're inserted from this side is the order in which they're going to be pulled out the other side. In comparison, a stack, you put things in basically like through the top. Think of it like a stack of plates. You can't really get to the plate on the bottom until you've taken all the plates on top of it off. Otherwise, you're going to break the whole thing and you're going to topple over the stack. There's no metaphor for doing that in a computer science stack, but we can only take out the very last thing that we've put in, the most recent thing that we've put in. So if I put a bunch of stuff in here, maybe we have one thing we need to do, then we put another thing we need to do, then we put another thing we need to do. So now we have three things stacked on top of each other. I can only take that top thing out and process it. And then I take the second top thing out and process it. And then I can take that last thing out and process it. So it's just a different way of organizing things that need to be processed later. And it forces us to process them in a specific order. The reason for the queue is because the first thing that finishes is the first thing that we want to process. And so it's natural that the first thing that goes in is the first thing that comes out. Whereas this call stack is better for modeling like sort of like nested things that we want to execute. So if I have like a function here, foobar, and I have another function, baz, and foobar calls baz, and baz does console.log foobar baz, and then down here I call foobar function. The reason why we model function calls in particular in a stack is that when I call foobar, the bottom of my stack is now that I am currently executing foobar. Only when I am finished executing this function can I take this off the call stack. We're no longer executing it. But this foobar calls Baz. So now I have to wait for Baz to finish before I can take foobar off the stack. So now Baz goes on top of the stack. And now we're going to console.log here. Well, this one is really easy. I can do this immediately. It just prints and then we're done. And now Baz is finished. We did everything in Baz. We console.logged. So now I can take Baz off the stack. And now we've done everything in foobar because Baz is finished. Now I can take foobar off the stack. So we can only process things, the last thing that got put in from the top to the bottom. Stacks, I think, are more complicated than queues. Queues generally are like pretty straightforward. But understanding like when is a good time to use a stack is sometimes a little difficult. I personally do not find that I use a lot of stacks, just like modeling my own data in projects. But it's a very, very important tool for like runtime engines and for like data structures implemented by different languages. It's a very very useful thing at a lower level. Sometimes it's useful at a higher level for the kind of things you're doing, but I find it less useful than a queue. All right, that was a lot of stuff to dump on you. We didn't even end up doing the chat thing. I think we found some more important stuff to do here. I will stick around for a couple minutes for questions. I know I went through things really fast, and at the end for the last 10 minutes, I just like talked at you guys, which I hate doing, but I thought of some other stuff that I thought might be helpful. Feel free to stick around, ask some questions. Feel free to drop out. Make sure you fill out the sign-in form before you go, please. It's in the agenda. I'll post it one more time. I will take attendance after this session. Thanks, guys. I'll probably see you next week.
Where should we sign up for the? Where can I find the link for this webpage?
I think I just posted it in the chat, forums.gle.
Okay, I got it. Thank you.
Yeah. All right. Hearing no other questions, I'm going to call it for today. Feel free to reach out if you get stuck at any point or you have anything that you want to follow up on. Also, feel free to
Thank you so much.
look at the examples. I know we didn't get to the WebSocket like chat room stuff, but that code is completed on that GitHub link in the agenda if you want to look at it. All right. See you guys next week.
Bye.
Thank you. Good night.